Yes, students, now we will discuss about revisiting rational numbers and their decimal expansions. In previous class you have learned about how to differentiate a rational number as a terminating decimal. We have decimal forms, right after writing a decimal form of rational number, we can divide into three types. One is terminating decimal. Terminating decimal means that the decimal expansion will end. For example, let us we take 5 by 2. Example, 2 is a 4, 1 is a 2, 5. There is no, it never contains. It never repeats. One more example, 503 by 100. Let us we take. If we divide by 100, it becomes 5.03. Is it repeating? No. That ends. If we can write a rational number as a form of decimal. In decimal form, if it ends with one digit of decimal point, it ends with one digit. There is end. That is called terminating decimal. But there is no end. It repeats. It repeats infinitely. That is called non-terminating decimal. Terminating decimals, non-terminating decimals. Terminating decimals means we can write the rational number in the form of decimal form or decimal numbers, as the decimal numbers are in decimal form with end with one digit after decimal point. Sometimes it may be big. That's not an issue. Example. Here, how many digits are there? 1, 2, 3, 4, 5 digits. 1, 2, 5. So, you know earlier classes. Is it ending with one digit or not after decimal point? Though it is bigger number, it is ending. This is type of number terminating. But some numbers, no end. Again, non-terminating decimals are of two types. The two types. You learned this basic point in earlier previous class. 9th class only. Non-terminating, non-repeating. Non-terminating, repeating decimal. Sorry. Repeating decimal. For example, 10 by 3. If you take 3 3 is a 9, 3 3 is a 3 3 is a, we can write 3.3 bar. So when we can write a decimal number as a non-terminating repeating decimal. That is why rational numbers are two types in decimal forms. One is terminating decimals, non-terminating repeating decimals. We have many. So let us discuss with examples. But this is an irrational number. Non-terminating, non-repeating. In some textbook they give non-recurring also. Whatever may be same. Non-repeating decimals. Same part doesn't repeat. The same part of decimal point doesn't repeat. Examples, square root of numbers which are not perfect square. Root 2 value we know 1.414 up to so on. Same part doesn't repeat. Root 3 also 1.732 up to so on. Same part doesn't repeat. Or else let us take one more example. 7.107, 1007, 1007, so on. There is no end, and of decimal point same part is not repeating. Here 10, 100, 1000, so on. This type of numbers are called non-terminating, non-repeating decimal. Those numbers are called as irrational numbers. So we can write a decimal form of any number. Actually it is not rational. Decimal form of any real number. Actually real number. That is terminating decimal, non-terminating decimals. Non-terminating decimals again two types. Non-terminating repeating decimals, non-terminating, non-repeating decimals. Terminating decimals are nothing but rational numbers. It ends with one digit. But non-terminating, non-terminating repeating decimals, of course, these are also rational numbers. But there is no end. Same part will repeat. I mean, same part. For example, one more example I'll give. 13.576, 576, so on. I mean, we can write in a bar form, 576 bar. You learn about these type of numbers in 9th class. These are also rational numbers. These two are rational numbers, but some kind non-terminating, non-repeating. I mean, same part doesn't repeat like this. Yes, see, different decimals are different digits are repeating. Even root 2, root 3 are called as irrationals, as you learn earlier class. So students, we have different kinds of numbers, decimal form of real numbers. Those are terminating, non-terminating, repeating, non-terminating, non-repeating. These we won't discuss now. Irrational numbers already we discussed. But in this exercise, evaluating of rational numbers only and their decimal form. Rational numbers means these two only rational numbers. Rational numbers are possible, I mean, decimal form of rational numbers are possible either in the form of terminating or else non-terminating repeating decimals. In which condition they are terminating, in which condition they are non-terminating repeating, you will learn. Let us discuss now. We have one small technique or small definition regarding this, how to differentiate terminating decimal or non-terminating repeating decimals of a rational number. Let us discuss. See students, terminating decimal. First, I will say the point. If, see, note it down students, if any rational number is in the form of, let me take x is the rational number where p by q and the prime factors of q, I mean denominator, are only 2 or 5 or both, then that is, then p by q is terminating decimal. I mean, it ends with one number. This is definition for terminating decimal. Let us see, any rational numbers are given. If it is in form of p by q, then if you write prime factors of q, I mean denominator, prime factors of q are only 2 or 5, sometimes are both, then p by q is terminating decimal. Let us take one example students. So here it's given that see, let us take one example, that is 13 by 3125. Write 3125 as prime factors. It is not possible. 2 table, 3 table. So we can take 5 table. 5 6 5 2 5 5. Again 5 table only 125. Again 5 10 2 only 25. 5 5. Continue. Then we can write 13 by 5 power 1 2 3 4 5 5. Means here denominator is containing only 5 as factor. 2 means simply we can write 2 power 0 if you want. Like this, if denominator contains either 2 or 5 or both, after writing prime factorization of denominator, I mean by using fundamental theorem of arithmetic, if you write always it contains either 2 or 5 or both as factors, that is terminating decimals. How to? See students, after factorizing denominator, what will be the highest exponent after writing product of either 2 or 5 or both? What will be the highest power exponent? After that many digits, the decimal point may come in the digit. I mean, after that many digits, decimal point may come from right to left of the decimal form of the digit. So these are terminating decimal. What about non-terminating decimal? So terminating decimal of a rational number, terminating decimal form of a rational number, we can define that When x is given, p by q is a rational number, prime factors of q are only 2 or 5 or both, then I mean exponent form of 2 or 5 or both, then p by q is a terminating decimal. This is one of the examples. Let us we discuss about non-terminating repeating decimal. That is nothing but a rational number. See students, non-terminating, we can write rational numbers in the decimal form. Only two terminating decimals, non-terminating repeating. Non-terminating, non-repeating decimals are not rational, they are irrational number. So, let x is equal to p by q is a rational number. If q has prime factors other than 2 or 5, then it is non-terminating repeating decimal, because a rational number is only two forms, repeating decimals. And one more thing students, we should apply this rule or previous rule. If it is lowest form of fraction or both are co-primes only, means for suppose let me take 15 by 1600. Yes, to check whether it is non-terminating or not, we should not apply directly. First write lowest form of this, because these two have common factor 5. 5 3s are 2s are 20. So 3 by 320. So now we have to apply 320. We can write 2 table 160, 2 table 80, 40, 20, 10, 5, 5. So we can write 3 by 2 power how many? 1, 2, 3, 5, 6. So 2 power 6 into 5. Now it is a terminating decimal. It is not non-terminating because it contains only 2 or 5. But let us we take, so this is terminating. Let us we take one example, one counter example for proving non-terminating also. I mean non-terminating repeating also. Let us we take 450. 64 by 455. Let me check, is it lowest form of this fraction? 64 and 445 doesn't have any common factors. Now write 455 as product of primes. 5, 5, 10 plus 4, 14. It's not possible in 2 tables, 3 tables. Next 5 table, 91. 91 is possible in 7 table. 7 1s are 7 1s are 7 3s are 13 only possible. So we can write 64 by 5 into 7 into 13. As we discussed students, if it is contains factors other than 2 or 5. 5 is there. Of course, how 2 is there means we can write 2 power 0, nothing wrong. 2 is there, 5 is there. But other than 2 or 5, one more is there, not 2 more are there. If contains at least 1 also, it is non-terminating repeating decimal. Of course, it is rational number, but it is non-terminating repeating decimal. So from this point, I mean in this way, we can differentiate rational numbers as terminating decimals or non-terminating repeating decimals. So let us discuss. And one more thing students, if it is terminating decimals, after how many digits the decimal point will come, also we can say how. We will discuss some example problems, exercise problems, then after we will differentiate terminating, I mean rational and irrational numbers in their decimal forms. Then after we'll conclude this chapter with that. Let us we take here in exercise 1.4, that is given in first bit, without actually performing the long division, state whether the following rational numbers will have terminating decimal expansion or non-terminating repeating decimal expansion. Because rational numbers will contain only 2 types, that is terminating decimal expansion or non-terminating decimal expansion. So while checking terminating or non-terminating decimal expansion, first we will write it is in the form of, lowest form of those numbers. Then after we will conclude whether it is terminating or non-terminating decimal expansion. So let us we discuss some problems regarding. So let us we take one problem, that is 29. Already in that first bit is explained, third is explained, second you will get as first, second, first, third, fourth we discuss. So second we will get as homework, you will get as homework. Now fourth one, it is given 29 by 343. But before checking whether it is terminating or non-terminating decimal expansion, let us we check whether it is lowest form or not. 29, 343, no common factors. Now let us we factorize this. 343 is not possible in 3 table, 2 table, 5 table. So 7 table, let us we check. 7 4 is 28. So we have 63, 7 9 the yes possible. 7 7 the yes possible. So we can write 343. Decimal denominator as 7 power 3. So denominator contains denominator contains 7 as a prime factor. So it is non-terminating repeating decimal. Non-terminating repeating decimal. So we can prove by using this. First step, check whether it is lowest form of fraction or not. After, write the denominator as product of primes. If the denominator contains other than 2 or 5, that is non-terminating repeating decimal. If it contain only 2 or 5 as common factor, it is a terminating decimal expansion. Let us we discuss one more problem. See students, in the sixth one is given 23 by 2 power 3 into 5 power 4. Let us we take. See students, here denominator contains 2 or 5 as common factor. Here in above, if it is given directly, we can write directly students. In above, denominator contains 2 or 5, 2 and 5, because both are there, 2 and 5 as factors. So it is a terminating decimal. Students, if it is terminating decimals, we can say after how many digits, after how many digits a decimal point will come, or else how many digits will come after decimal point, we can conclude. Because first step, check whether it is terminating decimals or not. If it is terminating decimal, check what is which exponent is larger number. Here 4 is larger. After writing as prime factors 2 or 5 in exponent form, highest number digits it ends, because we should make into 10 power 4. To make 10 power 4, let us we discuss how. 23 into 2, because to make 2 power 3 as 2 power 4, which is equals to 5 power 4, we multiply. So 23 2 is 46 by 2 power 3 into 2 power 1, 2 power 4, we can write 2 into 5 whole power 4, as you know, loss of exponent, 10 power 4. 10 power 4 means what, students? 10 after how many digits will come? 4 digits. So here we can conclude that 0.0046. This is the decimal expansion. How many digits are there? 1, 2, 3, 4. How we can conclude? Without doing this, we can conclude that after 4 digits, after decimal point, 4 digits will come. A question may get like this for 1 mark bit. In this expansion, sometimes they may not give this. They may give as a composite number of writing as prime factors. Which exponent is highest of 2 or 5? If it is terminating only, we can say students. If it is non-terminating, repeating, not possible. So, what is the highest exponent? That many digits it ends. So, this is the way to check directly whether it is terminating or non-terminating. If it is terminating, after this decimal point, how many digits will come? We can conclude without doing this process. If want this is the process to find the decimal expansion of terminating decimal. This is the revisiting of decimal form of a rational number. Let us discuss second bit. So in second bit same form we discussed directly even second bit also how to write. Or let us discuss one more example problem regarding. So it is second bit is given that write down the decimal expansion of those rational numbers in question 1. Show above have terminating decimal expansion. In second bit we will do same but condition which have terminating decimal expansion only we will write, not everything. So let us discuss one problem. So here terminating decimal expansion means, let us take one example 3. I'll explain third problem. Similarly you do rest of the problem. Fourth I will explain. That is 15 by 1600. If it is not lowest form, first step, write lowest form of this one as we discussed. 5 3 is 15, 2 is 5 3 is 15, 1 is 2 is 10, 20, 320. 3 by 320 write in decimal form. That is 2 160, 280, 240s, 220s, 2 10s, 2 5s, 5 ones. Means 2 power 1, 2, 3, 4, 5, 6. 2 power 6 into 5 power 1. So when we have 2 power 6, so 2 power 6, to make it this one as equal, we should multiply denominator. See students, by seeing this directly we can conclude after 6 digit decimal point will end. After decimal point 6 digits will come. So to make it power 6, let me multiply by 5 power 5. It is possible when they have terminating decimal. 5 power 5 value you have to. So if you take 5 power 5, that is if you multiply total, it becomes 9375 by 2 into 5 whole power 6. That is equals to 9375 by 9375 by 10 power 6 means 9375 by 1 after 1, 2, 3, 4, 6, 0 point. When we have 6 zeros, it becomes 6, 1, 2, 9, 3, 7, 5. Because when we have 4 digits, 2 more digits of decimal point, zeros will come. This is the way to write a decimal expansion of a terminating decimal. First step, we will check whether it is lowest form or not. After that, this write as prime factors we have. Then after what, without multiplication also we can conclude after decimal points how many digits will come. Because highest exponent of these two will be of how many digits will come of decimal point we can conclude. But it is given right decimal form also. That is why we are making 2 and 5 same powers. That is why we are multiplying 5 power 1, we are making as 5 power 6. That is why multiply by 5 power 5, both numerator and denominator. After we got 3 into 5 power 5 value, that's 9375. If you want, you can do. Then after 2 into 5 whole power 6, that is 10 power 6, means 1 after 6 zeros. So 6 digits we should get. So 4 already is there. Next 2 will take zeros. When we have less digits, we will follow this method as you learned earlier class. Now last model of the problem, this exercise we will complete. With that we will complete this chapter also. So please revise thoroughly, students. So these are the modules you have learned about how to write decimal expansion of terminating and non-terminating repeating decimal, which are rational numbers. Irrational numbers, non-terminating, repeating. Third bit is about differentiating or dividing into rational and irrational number. Now third bit, which is last bit of this. So here it's given that the following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they rational and of the form p by q, what do you say about prime factors of q? If it is rational, let us take one number 43.1, 2, 3, 4, 5, 6, 7, 8, 9. If you observe, there is the end of decimal point. It is ending. Of course, 9 digits are there. There doesn't matter. Ending. So it is a terminating decimal. So it is a rational number. Terminating decimal. And if it is terminating decimal, students, we can write 43.1, 2, 3, 4, 5, 6, 7, 8, 9 is in the form of p by q. So q contains only 2 or 5 or both as factors. So students, we discussed very first the definition of terminating and non-terminating repeating decimal. It is a terminating decimal as per the definition. But is terminating decimal, we can write p by q form. Even non-terminating repeating also p by q. But q means denominator, contains only 2 or 5 or both as factors by the definition. So we can conclude. It is given what are the possible factors of denominator. Second, let us discuss second one. Second one, if you take, students, if you see second one, that is 0.120, 1200, 12000, so on. It is a non-terminating, non-repeating, means irrational number. See 120, 1200, 12300 means same part is not repeating. Non-terminating, non-repeating means it is a irrational number. It is irrational. It is irrational. Of course, irrational also real number only. So for irrational number, we can't conclude it is not possible to write p by q form only. How can we conclude q contains 2 or 5 or both factors? So it is irrational. No need to discuss about this. When of decimal point same part is not repeating, they are called non-terminating, non-repeating. As you learn in a previous class, 9th class, they are irrational number. So it is irrational. So for irrational number, no need to think of. I mean, we can't write p by q form. How can we write the form of q as the factors of prime? Let us we discuss third one. Okay, students. So it is given 43.1, 2, 3, 4, 5, 6, 7, 8, 9 bar. It is a non-terminating. Of course, it is real number only. Non-terminating, repeating decimal. So it is a real number. I mean, it is a rational number, repeating decimal. See, students, terminating decimal contain 2 or 5 factors. Therefore, so we can write even this one 43.1, 2, 3, 4, 5, 6, 7, 8, 9 bar. We can write p by q form because it is a rational number. So non-terminating, repeating decimals, terminating decimal, both are rational. So if it is rational also, but it is a non-terminating repeating, so q contains factors other than 2 or 5. I mean, it may contain even 2 or 5 as factors, but other than 2 or 5, which are prime numbers. So it contains prime factors. Prime factors contains prime factors other than 2 or 5, means it may contain 3, 7. It contains only as prime factors. Please mention clearly prime factors. But here it contains prime factors other than prime factors other than 2 or 5. So you can go through textbook, students, everything is given detailed. So these are the concepts you have learned in first chapter. So please revise well and complete your classwork as a part of portfolio, including home assignment problems. Still, if you have doubt regarding, you can ask after coming back to school. So till now, what you have done: real numbers completed, polynomials completed, pair of linear equation problems about to complete. So whatever may be, what are the concepts you have so far covered? Please put in your question in your notebook and maintain portfolio and stick backside of classwork as home assignment. Complete it. Still, if you have doubt after coming back to school, you can get clarification. So these are the concepts you will learn in real numbers. First one about Euclid division lemma. Second, fundamental theorem of arithmetic. Third one, revisiting irrational numbers. Fourth one, revisiting rational numbers and their decimal expansion. That is terminating, non-terminating, repeating. Even you learn about non-terminating, non-repeating decimal expansion also. Thank you.